by 100, right? So let's take a look at the question. This is the information, and they ask you, what is the mean height here? What is the mean height for this item? Which is, again, reminder, right in the middle of your normally distribution is your mean, which is, everybody see that the mean is 63.7. Whatever this thing is, right in the center at the highest peak of your item, right in the center, that is your mean. And the unique thing that I did not mention about the normal distribution table, or not table, the normal distribution chart here is, graph here is, ideally the mean, the median, and the mode is at the same location. Okay, and again, if you collect any raw data, it will be very hard to find the mean, the median, and the mode at the same location. But again, for the normal distribution, that's what we have. The mean, the median, and the mode is at one particular location, which is in this case 63.7. Okay, and they ask you, what is the percentage of women between 57.4 and 59.1 inches tall? Which is, again, as you can see, between 57.4 and 59.1, everybody see that this is 0.034, which is, again, because they ask you for the percentage, this thing give you decimal because they ask you because they ask you for the percentage, we have to move the decimal 2 places, or we take this decimal and multiply to 100, just like the percentile back then, right? So again, in terms of this thing here, we have 3.4%, right, of the women between that height. And now they ask you, if there are 2,000 women at the stadium concert, how many of them would be expected to be between 63.7 and 66 inch tall? Which is, again, looking at this thing here, given this item here, the only information they give us, or we have, is 0.303, which is, again, to find this thing here, all we need to do is take the area or the percentage, multiply by the total number of people, right? So again, if you take this 0.303 multiply to 2,000, you will have 606 people, right? We expect 606 women to be between those age, or not age, the height, right? Between those height. So given this data, they give you the percentage, right? And again, they give you a percentage, so all we do is we take this percentage and we use in terms of what they ask us, or in the sense of what are given to us, okay? And again, later on, we will use that same thing go, right? If we're trying to find the number of people, all we do is we take the percentage times the total number of people, right? If we have 1,000, like I say, let's say 35% of the people took the test, right? And if 100 people took the test, and if it's 35% pass, meaning, again, 35 out of the 100 passed the test, right? So again, I use 100 to make it easy in terms that the percentage is in the 100, right? So that's the idea here, is we using this probability or this area under the curve to illustrate the probability, as you will see later, okay? But again, let's dive into more of the normal distribution table. So I think this is where a lot of students have problem with, is the empirical rule, okay? So the normal distribution table have this called empirical rule, or some book they say the 68, 95, 99.7% rule, right? So again, 68, 95, 99.7% rule. So what does this empirical rule say? Well, the empirical rule says this: if your data are normally distributed, meaning, again, the only reason why they say normally distributed is, ladies and gentlemen, is your data is symmetric, is a bell-shaped curve. If they don't say normally distributed, meaning, again, your data can be skewed to the left or skewed to the right, or kind of scatter, is not bell-shaped curve. So again, the only reason why they say normally distributed, and most of the question they would say normally distributed, so that we know that it's a bell-shaped curve. Okay, so they say that if they are normally distributed, meaning approximately 68% of your data will be within one standard deviation from the mean. Meaning, again, the word within, one thing is not with one standard deviation, is within. What does it mean? Within, meaning, again, you have to take one step up and one step down. All right, within one standard deviation, meaning it's +1 and -1, which is, they say, if you take one step up and one step down, that is not 68% of your data. If you take two steps, if you take within 2 standard deviation, 95% of your data. And if you take 3 steps, if you take within 3 standard deviation, 99.7% of your data. Right? And again, think about this thing here. As you can see, near the mean, at the middle here, do you agree that's the highest peak of my graph, right? And again, this is basically tell you that because the mean is right here, and because this is the highest peak of the graph, that is why most of the population, most of the data is surrounded the mean. 68%, and as we go further, as you can see, our graph gets smaller and smaller, meaning it's covered less and less and less and less and less of the data. So again, 95% of your data is within 2 standard deviations. And again, 99.7 are within 3 standard deviations. Again, that is your empirical rule. It's basically, again, to think about this thing here is basically, if you take one step up and one step down, 68% of your data. If you take 2 steps up and 2 steps down, that is 95% of your data. And if you take 3 steps up and 3 steps down, that will be 99.7% of your data. Okay? So the X bar here is your mean, and the F is your sample standard deviation. Okay? So again, this is what we have here. If you look at this thing here, the X bar, it just tells you that is your mean. If you add 1 standard deviation and subtract 1 standard deviation, that means within 1 standard deviation, 68, and so on and so forth. Okay? So let's take a look at this. How do we use this empirical rule? How do we use this empirical rule to answer our problem? So they say that the intelligence test, the IQ test, is normally distributed. And again, like I mentioned, why do they say normally distributed? Meaning your data is symmetric, it's a bell-shaped curve. Okay? With the mean IQ is 100 and the standard deviation is 15. If there are 40,000 people taking the test, how many would you expect to have an IQ score between 70 and 130, right? So there are 2 parts of this thing here, which is, again, in order for us to know approximately how many people, we have to know the percentage. What are my range, or what are my cover of this item here, right? But again, just like always, as long as you have a word problem, ask yourself, what are they given to you guys, right? What are they given to us, which is, again, we know that this is what we have is a standard normal distribution, which is, this is what we have. And I will mention more about standard normal later, but again, what do they given us? Do you agree that this is the item they give us is the mean, which is X bar, is equal to 100. And the standard deviation, which is the S, is equal to 15, right? So hear me out here, guys. Hear me out. The standard deviation here is the thing. Remember last Wednesday, we calculated standard deviation, right? That is the same standard deviation we right here that we have. Meaning, again, they collect a lot of people took the test, right? And they find the mean, they find the data, subtract the mean, they do all the square and the square root, and they do the 6 steps that we did last Wednesday. to find the standard deviation. Now we got it. We don't need to